Okay, we're doing atomic structure guided notes today. So a lot of this is just review from honors chemistry, but I feel like we need to look at it just to remind you guys. Okay, so let's take a look at the picture up here. It says there are three isotopes of hydrogen, and they give the names of each one. It says, what do they have in common? So think to yourself, what do you think they have in common right now? Well, I noticed they are all hydrogen, so they all have the symbol hydrogen, right? Symbol H. So move it here, symbol H, because they're all hydrogen. I also noticed that this bottom number is the same. Okay, and so I'll just put right now we call it because we haven't labeled it yet. And then the next question says the difference between them. So I notice here the difference is the top number is different. So now we need to talk about what that means. So it says, what are the ions in common? So these ones here are ions. Notice they have a plus or minus. This is the regular atom. So I'll put that here. And this is when it's a positive, it's called a cation. When it's a negative charge, it's called an anion. Just something to remember. So what do ions have in common with other atoms? So if you'll notice, they all have that same bottom number. Okay, so I'm going to put right now bottom number until we define what that is. But you may in your head think, I know what that is, that's fine. How do ions have atoms? Well, it's this thing right here, right? They have a charge. And if you recall, the charge means it's either lost or gained an electron, or more than one electrons. So here, remember the electrons are negative, this means it lost an electron, and this guy gained an electron. And so we're going to put here they have a charge, which means they lost or gained an electron. Okay? All right, look at all the pictures above. What must all four of hydrogen have in common? So we circled at the beginning, they all have that one number. Do you remember what that number indicates? Well, they all have the same symbol as well. They all have hydrogen H. So besides that, they all have to have the same number of protons, which is what that number indicates on the bottom. Okay. All right, so let's define an atom. An atom is when the protons and electrons are equal. The ion is when the number electrons changes. And normally I would put on my paper changes as a triangle. So it will have the same number of protons and neutrons, but the number of electrons changes. An isotope is when the number of neutrons changes. I'll put there change. Okay, so this is called a nuclide symbol in this format here. The A stands for the atomic mass. The Z is the atomic number. C is the charge. And this X here is the element symbol. That's what they all stand for. Okay. All right, let's look down at the bottom here and answer questions about hydrogen. So, what does the top number of the table represent? So, if we're looking at it in this format, the number one is the atomic number, which is the same as saying the number of protons or electrons in a neutral atom. Because remember, in an ion, the electrons can change. What does the bottom number of the periodic table represent? It's not a perfect whole number, but it represents, first of all, it's called the atomic mass. And sometimes people call it the mass number. So I want to put that down here too. Mass number. Atomic mass though, and that's the protons plus neutrons. So just as a reminder what that is. And then it says, how is the bottom number calculated? It's a weighted, I'm going to put that here because we're going to go into more details about this. It's a weighted average of the masses of all the natural isotopes of the element by their abundance. So elements are isotopes, and remember that means different number of neutrons, and not every isotope is as prevalent. So that's what that's talking about here. It says by their abundance. So some are more prevalent than others. I'm going to show you the calculations. So the questions on the back, you don't necessarily, you can't really do them. We could do number one. We talked about how to do that, but we haven't talked about the rest. So before you try to do any, watch the rest of the notes.